Good morning students, welcome to the chemistry class. This session we are going to see the topic radial distribution function as well as angular distribution. Okay, so in radial distribution, for the aim for this radial distribution, talk about the distance for electron as well as nucleus. You know the concept, center of the atom is the nucleus. Electron is revolved around the nucleus. Now electron is present here or here, wherever. Okay. So now to find the distance between electron and nucleus. So this is the aim for, that is, talk about the radial distribution function. And next one, talk about the angular distribution. So in angular distribution, talk about the direction. In radial, talk about the distance, okay, of electron as well as nucleus. In angular distribution, talk about the angle. Okay, so in angle means now it is the sphere shape. If it is flat means you can find the angle, it is very easy. But this one angle, this one for sphere. Okay, so now to find out the angular distribution of, that is, electron as well as nucleus, this angle that is going to find out. Now it is a three-dimensional, that is the space. So that is the three coordinates, that is axis x, y and z. So angle, this angle as well as this, that is the pi. This one for theta, this variable, that is the pi. Okay. Now to find out the angle. So angular distribution. So it is denoted as here, that is direction. Are you clear, children? Okay, so now for this lesson, mainly discuss about only the electron. So till, that is, we are studying about only this electron. Okay, from the beginning onwards, from the Thomson model onwards, that is, we are discussing. In Thomson, electron is embedded in the sphere. Next one, Rutherford talk about center part is the nucleus, electron is revolved around. Bohr talk about this electron revolve around in the particular orbit, K shell, L shell, M shell, N shell, etc. Next one, talk about the duality. This electron has both the character, one is particle and another one is wave character. Okay. So next, Heisenberg uncertainty. Again talk about this electron. At the same time cannot be calculated position as well as momentum. Okay. So next, Schrödinger also talk about this electron in wave nature. So now continuously, that is, studied about this electron. In Schrödinger wave equation, that is, introduced the new term psi. In Schrödinger equation, all the terms we know except this. Okay. So now that is psi. This one that is called, the word as psi. Okay. Psi. Okay. So now psi means, that is the wave function of an electron. Electron, that is wave nature. Okay. So now this psi versus r, we cannot get clear idea about the distance. But at the same time, now it is multiplied, that is psi square versus r. Now to get a graph, to get clear idea about the distance. Okay, children. So in psi square versus r, talk about oneness orbital. Okay. So now see the graph, psi square. Okay. As sometimes that is to be given 4 pi r square psi square versus r. Now talk about oneness orbital. What about the distance from the nucleus? Okay. So now to get one graph, this is the peak. Okay, here that is value is, that is 0.5. Okay, 0.5. So this approximate value for this, that is 0.52 angstrom. This is a distance. Okay, so that is the probability density, that is 0.52, that is the Armstrong. So this value, it is equal to, already both discussed this value, the distance between nucleus as well as electron, 0.52 Armstrong. Same way for this also, that is the radial distribution concept also give the same value, so it is equal. Okay children, so now, and in radial distribution topic, talk about point number 1, distance between nucleus and the electron, concept number 1. Next, it discuss the node or nodal surface or nodal plane. Okay, this is a new term. So this node or nodal surface means the particular place the electron, it is not present, that is absence of electron. Okay, so now s orbital, that is it is a sphere shape. So now here electron, it is present anywhere else, it is not we cannot, that is say electron present here, or it is not possible to say. Okay, because it is present just that is within the sphere, the electron it is present, that alone we can, that is say, but it is not present this, it is not present, it is present here, you cannot, that is say such words in the s, or especially in the s orbital. Okay, so now this node calculation formula, now we are going to find out the node, or in where that is electron it is absent, we find out mean using the node formula n minus 1. So this is a node calculation formula for ns orbital only. Okay, in np as well as nd. Okay, np and nd orbital, here that is the formula is n minus l minus 1. Okay, so this one, that is the radial node calculation, n minus l minus 1. N denoted as the principal quantum number, L denoted as the azimuthal quantum number. Okay, so now see the 2s and 3s orbital, what is the distance. Okay, now we are going to calculate. Then now see the 2s orbital. In 2s orbital, talk about the distance as well as node. This is the concept. Okay, so in 2s orbital, now using the graphical representation and discussed. So now the graph is plotted between 4 pi r square psi square. Okay, psi square probability density, and r denoted as distance between nucleus and electron, this distance. Okay, so now draw the graph, see the graph, that's all. Okay, so now see here, first increases, again decreases, next it reaches 0, again increases, okay, at a maximum, again decreases and 0. So hereafter it denoted as no electron. Okay children, so now center nucleus, first electron, that is increases, probability of finding electron maximum, next no electron, and next one the probability of finding electron increases. So after maximum electron it reaches, hereafter that is no electron. So this alone, that is the top source from this, that is from the graph. Can you understand? Okay, so now see here, this position we are calling as, that is node, N-O-D-E. In this picture here it denoted as node. That means here have no electron. For the particular area, the electron it is absent. Okay, so in 2s orbital, this is a diagrammatic representation, we can find the node. So according to formula n minus 1, node calculation formula. Okay, node calculation formula, n principal quantum number. This 2s orbital, n value equal to 2. So 2 minus 1 equal to 1. So how many nodes present in 2s orbital? Only one node. Are you clear, children? So hereafter no electron. So here that is empty space, no electron. Are you clear, children? Okay, so now see the 3s orbital from the graphical representation. So this one distance. Okay, this also that is the distance from the nucleus. Now that is increases. Center nucleus. So first one 1s, it is closer. So next 2s, this one. Okay, now increases. The distance increases. So next one, talk about the 3s orbital from the graphical representation. For 1s orbital, this one 1s, next 2s, next 3s. Okay, so now the graph plotted between 4 pi r square psi square versus r. Okay, so now here to find out how many nodes are present in 3s orbital. Okay, according to formula n minus 1, node calculation formula, node calculation n for 3s orbital, n equal to 3. So 3 minus 1 equal to 2 nodes. Now see the graph. Now this area, here no electron. This area also no electron. So how many nodes? 2 nodes. Okay. So now talk about this, that is the electron distance. Okay. So now here first 1s orbital, that is increases. So now with the diagrammatic representation, nucleus. Now electron, it is the probability of electron. Okay, is maximum. The children see here, not all the dot are not electrons. Electron is present here or here or here, wherever, but it just randomly representing, put the dot. Are you clear, children? Okay, so next no node, so just leave it. This one for 2s orbital. Okay, so this one electron, that is excited, 2s. Next again have leave some space because no electron. Okay, so now this one for, that is the 3s electron. I hope, children, you can understand. For this one is very clearly. Now find out the distance, that is increases from the nucleus. Okay, this 1s alone, it is closer to the nucleus. So now the size is increases depending upon this number. This number mean that is the principal quantum number. Now the principal quantum number is increases, the size is increases. Okay, so here 1s orbital diagram like this. It is a spherical shape. Okay, so 3 axes, x axis, y axis and z axis. X, y and z axis, 1s orbital. In 2s orbital, now the size, that is increases. 2s orbital is a spherical shape. S orbital is the spherical shape. Okay, so next x axis, y axis, z axis. In 3s orbital, now size again, that is increases. 3s orbital. Are you clear? This is spherical in shape. 3s orbitals. X axis, y axis and z axis. Okay, so 3 axis. 3 axis, x, y and z. Children, you can understand very clearly, I hope. So 1s orbital, that is no node. 2s orbital, 1 node. In 3s orbital, 2 nodes. Okay, so nodes mean the particular place the electron, it is not present. At the same time, now the 1s orbital, that is maximum electron present up to this area only. So here after no 1s electron. Same way for 2s, that is orbital electron, it is present for this area only particularly. Okay, so here after no 2s orbital. Same way for 3s orbital also. So this one for only 3s orbital electrons. Okay, so here after again, that is no electron. So this also, that is the shows from this graph also. Okay, so 1s, 2s and 3s. Next, that is electron, that is 0. Children, now see the 3p orbital. Okay, so in ns orbital ns node calculation formula n minus 1. You must keep in your mind, this is very important. ns orbital node calculation formula n minus 1 in np as well as nd. Okay, so both also it is calculated, node calculation. np and nd formula, radial nodes calculation formula n minus l minus 1. n denoted as principal n, principal quantum number, principal quantum number. L azimuthal quantum number, azimuthal quantum number. Okay children, now in 3p orbital, what about the n value? So now n value equal to 3. And next L value, repeatedly I use this word, this L value you must keep in your mind. Azimuthal quantum number value 0, 1, 2, 3. Okay, so now the denoted the orbital L is equal to 0. It denoted the orbital is s orbital. Here 1 p orbital, 2 d orbital and f orbital. Okay, L is equal to 0 denoted as s orbital, L is equal to 1 denoted as p orbital, L equal to 2 d orbital, L equal to 3 denoted as f orbital. Are you clear children? Now p orbital, what about the L value? 1. Okay, so now substitute in the formula 3 minus 1 minus 1. Okay, so what is the answer? That is 1. Okay, so now what about the nodes in 3p orbital? That is only one node. So now from the formula we find out the nodes. Now I draw the graph. From the graph to find out how many nodes for 3p orbital. Now I draw the 3p orbital. This is a diagrammatic representation. Okay, this one for 3p orbital. So the previous one is 3s. So you see here, now to find out the nodes only. So now first increases maximum, again decreases, and here 0. So this one for node. Okay, so again it increases to reach the maximum and decrease the distance. So hereafter no electron. Okay, so how many nodes? Only one nodes. Can you understand from this graph children? Okay, so next one, now see the 3d orbital. Now the graph plotted between 4 pi r square psi square versus r. Okay, so now this one is represented as the 3d orbital. Okay, so this one 3d orbital. Here are any nodes? No nodes. Okay, now apply in the formula. What is the radial node formula? N minus L minus 1. N value 3. This alone denoted as n value. L value taken from d orbital. D orbital. What about the L value? 2. Okay. So next minus 1. So the answer, that is 0. That is no node. Even the graph also shows no nodes in 3d orbital. Children, for this area, especially in radial distribution function, the repeated question is expected from the node topics only. Repeatedly they are asking node. Okay, so keep in your mind, what about ns, what about nb and nd. So this formula, if you will keep in your mind, is very easy for the calculation. Okay, ns, what is the formula? N minus 1. Np as well as Nd, what is the formula? N minus L minus 1. Now see the topic angular distribution function. Angular distribution function. So from this topic we discuss the direction. Okay, so electron, now electron it is present in the sphere. Then it is revolve around the nucleus in sphere. Okay, circular path. So now to find out the direction, the previous part I discussed the distance. This value we are calculating for 1s orbital, and this distance whether it is increases 2s and 3s. Okay children, now we are discussing the angle. Angle here denoted word as direction. In which direction the electron it is present, whether it is x-axis or y-axis or z-axis. This is the concept for angular distribution function. So locating the position of electron. Locating the position of an electron. In which position of an electron. Are you clear? Okay, so now take the example for 1s orbital. So in 1s orbital, what about the n value? What about the L value? What about the m value? This n denoted as principal quantum number, L azimuthal quantum number, m magnetic quantum number. Okay, so this one is denoted as principal quantum number. So L value 0 for s orbital, m value also 0. Okay children, so in the beginning that is we discuss one formula, that is wave function psi that is equal to, that is a 3, that is the principal coordinate, that means it is a 3-dimensional, that is the arrangement, because it is the orbital 3-dimensional space. So it has 3 axes, x-axis, y-axis and z-axis. Now to find out the distance, okay, that is we are consider as the symbol as r, distance. Okay, next one angle theta. Another one that is the variable is, that is the pi. Okay, pi. So now here anywhere now electron to find out the distance, that is r. So now theta as well as pi. This 2 also denoted as the angular distribution function. This r denoted as the, what is that? That is the to measure the distance. This one for direction. Okay children. So now this one f as the function. So f theta. And next one, this one for pi. So here use the function as g. Okay. So this f theta value 1 by root 2. This one we consider for 1s orbital. Okay. So next one in g phi 1 by root 2 pi. Now to multiply this 2 f theta as well as now to find out the angular distribution. This one depends on the azimuthal quantum number. So this angular distribution equal to this f theta, okay, into g and pi. So this f theta value 1 by root 2 into 1 by root 2 pi. 1, okay, next step 1 by root 2 into root 2, that is 2. Here root pi. So root pi. Okay children. So this angular right here, okay, angular distribution, the value is 1 by 2 into root pi. This is the angular distribution function. So from this function, they will come to the conclusion in s orbital, the electron it is present in anywhere else. It is not present in x-axis, or it is not present in y-axis, or it is not present in z-axis. So it is present in the whole sphere anywhere else. Within the sphere, the electron it is present. So from this angular distribution function, come to the conclusion, the electron is present in anywhere, not the particular axis. So s orbital is a non-directional character. In p orbital is a directional path, because in p orbital the electron it is present in particular axis, whether it is x or y or z axis. But here it is not possible to say here present, it is not. Anywhere it is present, but it is present. Are you clear, children? So from the angular distribution function, talk about especially in the oneness orbital, the electron it is present in anywhere else, but it is a spherical in shape. Within the sphere, within the spherical, electron it is present. Now see the topic. Shape of p orbitals. Totally 4 orbitals: s orbital, p orbital, d orbital, and f orbital. S orbital is over. Okay, so till come to the conclusion, s orbital is spherical in shape. Spherical. Okay, so now we are going to discuss the p orbital. So in p orbital, now write the L value. L is equal to 1. Okay, L is equal to 1 means denoted as the p orbital. So m value. What is the magnetic quantum number formula? M equal to minus L, 0 and plus L. This is the formula. So minus 1, 0 and plus 1. So here have 3 values. Minus 1, 0 and plus 1. 3 values. So these 3 values denoted as the 3 coordinations. Okay. There is a 3 orientation. That means in the p orbital, this is a diagrammatic representation. 3 orientations. Okay. So in each orientation gives, it is coordinated with the axis x, y and z. 3 axes. It is one for p orbital. So px, py and pz. Okay. So 3 orientation for p orbital. In s orbital, only 1 orientation. Okay, so here I have no direction, because electron it is present everywhere. Okay, within the sphere. So here we are just representing only the 1s or 2s or 3s, whatever just mentioned. But here electron it is present in x-axis, electron present in y-axis, electron present in z-axis. So it is the directional character, direction. So it has the angular distribution of function. Angular talk about the direction. Okay, so in that is a 3 that is the axis. So px, py and pz. Okay, so now draw the diagrammatic representation. So here the electron it is present. This one for x-axis. Okay, y-axis is one z-axis. So now in px orbital, the electron it is present here. So here means we call that is the terms as LOBE, lobe. Okay, so this 2 lobe, this one side lobe, this is another one lobe. So this 2 lobe meet at a point here. This point is called as node, because p orbital that is one node. Okay, so now see here. Okay, so that is a p orbital, that is one node. So here that is only one. Here electron it is absent. So now here the nodal plane is x, electron it is present. Y as well as z, that is electron is absent. So nodal plane is, that means this one node, that is y z. In your textbook given nodal plane, y z symbol is given. So this one represented as, here electron it is absent. So same way for p y orbital. Now this one to consider as p y, x-axis, y and z. Now electron present in y-axis, So this one it is called as lobe. This is another lobe. So two lobe meet at a point. It is called as node or nodal plane. Okay, so here the nodal plane is because in Y electron it is present. So the nodal plane is XZ. Okay children. So now this one diagram for PY. So nodal plane is nodal plane. Okay, nodal plane for XZ. In PZ, here Z axis. Electron is present here. Okay, this one Z axis, so X axis, Y axis. So representing PZ. Electron it is present here. Okay, so this one called as dumbbell shape. Dump, D-U-M-B, dumbbell shape is look like that, dumbbell shape. Okay, so here this position is the node or nodal plane. So now here Z electron it is present. So X as well as electron it is absent. So X as well as Y is the nodal plane for PZ. This one nodal plane for PZ orbitals. Okay children. So here the electron it is present in a particular direction. Talk about in P orbital. But S orbital it is not. Talk about that is S orbital. Electron it is present within the sphere anywhere. This session the area one is radial distribution, angular distribution and the shape of P orbital. This is just a summary. Okay, in radial distribution talk about the distance. Okay, so distance of electron. Okay, nucleus and electron. So this distance calculating, as well as the another one important concept, node calculation. Okay, node means electron, the particular place is absent. So two formula for NS, this formula, for NP use this formula, NP as well as ND. Okay, so in angular distribution it depends, here have two formulas. Same way for in angular distribution the formula is, that means it depends on L. So L, that's all. And angular distribution talk about location of electron. Electron it is present here or it is present here. Talk about the location, angular distribution. We using the word direction. Okay, so next one P orbital, L value 1, so M value -1, 0, +1, so 3 values. So this 3 values denoted as 3 coordination or 3 axis. Next geometry, the shape, dumbbell shape. Here 3 orientation. Children, I hope you understand this session. Thank you.